Hello everybody. All right, we are going to work on the logarithms practice test. So if you were absent Tuesday, March 17th, St. Patrick's Day, this would be what you missed. All right, so numbers 1 and 2 are kind of backwards from each other. So one is going from exponent form into log form. The other one is going from log form into exponent form. Something that we would use for this is that this is exponent form, and then this is log form. And we call this my friend Ben, and we call this my friend log Benny, right? I'm going to make this a capital E so we don't get confused with Euler's number. So the 7 is the B, so in my reply it's going to be the B in the log. The P here is the exponent there is going to be after the equal sign here. The N here is 12 is going to go here. And we would say that log base 7 of 12 equals P. And now we do it the other way around here. So the 5 is the B, the 20 is the N, and the A is the exponent. So we get 5 to the A equals 20. I really encourage you to write this part down and then to label them if that helps you. Number 3 says fully condense. When we fully condense, our answer is going to end with the word log only once. On one side of the equal sign, if we're doing it with equations where we're solving, and no leading coefficients. Okay? So I know that this is not condensed because I have the word log twice. In your notes, you have a property for when we add logs. When you condense them, you get to do log base 3, and then whatever is here and whatever is here ends up multiplied together. So we would get 7x, 7 times x. You might put the multiplication dot in between, but I would prefer it not, because that shows me that you understand that this would be multiplication, 7 times x. Doing it again, here we have the log written twice, so I need to condense them so I get the word log written only once. And when we're subtracting logs, the property shows us that we get to divide them. Log base 4 of 12 over 3. Now, some people were writing that that equals 4 because 12 divided by 3 does equal 4, but that is not correct. You have to actually write that it becomes log base 4 of 4. Now that does in fact equal 1, so that would be a good thing to note, right? Because if the base and the number are the same, it is always 4. Sorry, it is always 1. I apologize, I misspoke. Now number 5 combines all 3 of our properties that we learned. So the first one is the product property, that this leading coefficient of 2 is going to become a squared. So we get log base 9 of 4 squared minus, there's nothing leading here, so I'm just going to copy it again, log base 9 of 2. Plus, I have a leading coefficient again, so I'm going to make that an exponent, log base 9 of x to the 3rd power. Now from here, we're going to treat just this part like one problem, because PEMDAS tells us that we do addition and subtraction as they appear from left to right. So this would look just like number 4. It's going to become division. So we get log base 9 of 4 squared, which is 16, divided by 2. The 2 came from here. The 4 squared became 16, plus log base 9 of x to the third. This, right, equals 8. So it will become log base 9 of 8. Now we had an addition problem. In addition, we get to multiply this one times that one. So we get 8x to the third. And now we have the word log only once with no leading coefficient. So that is my answer. Now to fully expand the word log will be written more than once, and there will be no exponents. So when we're condensing, we want the exponents, but when we're expanding, we want the leading coefficients, okay? So there is a place in your notes that mentions fractional exponents become radical signs. Well, the opposite is also true. Radical signs become fractional exponents. So this radical sign will end up being log, and then this is all under the radical sign. So we put parentheses around it because the whole thing gets the fractional exponent. So we get 9x squared in parentheses to the 1/3. There was an invisible 1 out here. That's what becomes the numerator. And then the 3 becomes the denominator of our fractional exponent. From there, our exponent rules from Module 6 tell us that the 1/3 gets multiplied times the exponents that are inside. So we get log of 9 to the 1/3, because 1/3 times 1 is 1/3, x to the, what is 2 times 1/3? It is 2/3. It feels like we've done a lot already, but we still don't have the word log more than one time. We only have it once, so I can't be done yet. We have a multiplication problem here, so that means we can change it into an addition problem. So we're going to go log of 9 to the 1/3 plus log of x to the 2/3. Beautiful. So we have the word log more than once, and there will be no exponents. So our exponents need to go out in front to become leading coefficients. So we end up with the answer of 1/3 log of 9 plus 2/3 log of x. Oh my gosh, we don't even have a base here. What would the base be? Yeah, this is all base 10, but base 10 is our common base, so we don't even have to write it. All right, flipping over to the other side. Now, all of these are solved for the variable in check. So these are in our notes where we did notes on log equals log or log equals number. Okay? We did this one on Friday the 13th, so if you don't know those notes, you should watch that video if there is one. And then log versus log, I think, was on March 6th. Sorry, now I'm going to stop and look to make sure, because these are the notes for log equals number. We took them on the 13th, and there were 2 pages of them. Okay? If I go back a few, yeah, They would be from March 6th, and it was the type 1 log equals log. And so our steps for log equals log is going to be, we need to condense them, use the one-to-one property, which is gorgeous, because it says if you have log base b of m equals log base b of n, then you can cross out the log base b's and just write that m equals n. Then you solve for the variable, like in Algebra 1, and then we check for extraneous solutions. So let's go do that. So here, both sides are condensed. We have the word log only once, we have the word log only once. They are both condensed. So we can ignore the word log base 7 and write 5n minus 33 equals negative 6n. From there, we need to solve for n, so I need them on the same side. I'm going to go plus 6n to both sides so that I don't have to deal with a negative n, giving me 11n minus 33 equals 0. Plus 33 to both sides, so I get 11n equals 33. Divide by 11, divide by 11, we get n equals 3. Yay! Make sure that we check that we don't get a negative log. So I take 3 and I'm going to plug it in here. So we go log base 7 of 5n minus 33. 5 times 3 minus 33. 5 times 3 is 15 minus 33. I don't know what it is, but I know it's going to be negative, so this does not work. So I'm going to write no solution because we get a negative log when we plug in 3. You can also see it right here that negative 6 times 3 will be negative 18. So there's just no way. It doesn't work in either one. So this one is no solution. Notice, if you did not check, you would have done all of this work, gotten n equals 3, and your answer is wrong. And you would have to fix it in a test reflection. All right. Number 8. On this one, we have log one time on the left, so it is condensed. But on the right, we have log written twice, so it is not condensed. The rule for when you're adding logs is that you get to multiply the other stuff, right? So very similar to number 3, where we were adding. And so adding logs means we multiply when we condense them. So 7 times x. So here we get to rewrite the first side. Log base 4 of 88 equals log base 4 of 4 times 3h minus 2. Then you can double parentheses that. And you guys are really good at this. We're going to distribute the 4. So we get log base 4 of 88 equals log base 4 of parentheses 12h minus 8. Now that both sides are condensed, we can use the one-to-one property, which says that if we have log base 4 and log base 4, we can ignore those, and now we have 88 equals all of this, 12h minus 8. Now it is an Algebra 1 problem. We can add 8 to both sides. We get 96 equals 12h. Divide by 12, divide by 12, 8 equals h. Hopefully that is our answer. We need to check. Taking 8, there's not even an h on this side, so we're fine. There's not an h there, that's fine. So our only one we have to worry about is 3h minus 2. Will that be negative? 3 times 8 is 24 minus 2 is 22. So it is fine, it checks. Putting the little check mark will really put me at ease that you actually did the checking, because sometimes you can check in your head. So putting the check mark is helpful. Number 9. Number 9 gets pretty complicated, so take a breath, right? This side is condensed because we only have the word log once. There's no leading coefficient, so we can cross it out and write d squared minus 12 equals d. I have a d squared, so that means I'm going to have 2 answers. So I'm going to subtract d to both sides to get it into the quadratic equation style. So we've got d squared minus d minus 12 equals 0. From there, I would like to know what a equals, what b equals, and what c equals. Try to do it without me. You should be trying everything without me first, right? So there is an invisible 1 here, so a is 1. There is an invisible 1 here, so d is negative 1. And then c is negative 12. From here, we need to put it into our magic x. Reminder that the top is a times c, and we multiply to get that. You add to get the bottom, and then we have, and then the bottom is going to be b. A is 1, so that's not a problem this time, so we get negative 12 at the top. The bottom will be negative 1. Then we need to list all of the things that multiply to make 12. So we get 1 times 12, 2 times 6, 3 times 4. If I add 1 and 12, that's 13. If I subtract them, that's 11. That does not give me negative 1. 2 and 6. If I add them, I get 8. If I subtract them, I get 4. That is not negative 1. 3 and 4. If I add them, I get 7. If I subtract them, I get 1. That's where I'm going to need my negative 1, so I get 3 and 4. If we make the 4 negative, that'll give us negative 1. So our variable is d, so we get d plus 3. And then we get d minus 4. If our a had been anything besides 1, we would need to slip and slide it down here, do the division. You can go back to module 4 to look at how that's done. Then we set these equal to 0. So I get d plus 3 equals 0, and then d minus 4 equals 0. Minus 3 to both sides, d equals negative 3. Plus 4 to both sides, d equals 4. Yay! My only step left is to check for negatives, right? I'm going to start with this one, d, because that's no work at all, right? D equals negative 3. Boom. That one does not work because I cannot have a log of a negative. D equals 4. Oh, if I put 4 in there, it's fine. So maybe that's still good. I do need to check it with the other one. 4 squared would be 16. 16 minus 12 would be 4. So that one is correct. That one works. Number 10. Actually, I'm going to go to number 11 first because number 11 is still a log equals log problem, and number 10 is different. So let's continue on the path we're on, and then we'll go to number 10 afterwards. All right, log base 4 of 3p plus log base 4 of quantity p minus 2 equals log base 4 of 6p. Notice this empty spot here. It messes with my head a little bit. So I am thinking of giving you a bonus point where you have to read a problem like this to me. So you might want to practice that. Log base 4 of 3p plus log base 4 of p minus 2, the quantity of that, equals log base 4 of 6p. All right. This is not condensed, though, because I have the word log twice. So I need to condense it. We are adding, so that means I'm going to multiply those two. So we get log base 4 of 3p times p minus 2, double parentheses, equals log base 4 of 6p. Now we do the distributing, which you guys are really good at. So we get log base 4. 3p times p is 3p squared. 3p times negative 2 is negative 6p. That needs to be in parentheses still. Equals log base 4, parentheses 6p. Now both sides are condensed, right? So they're both condensed. Now I can use the property, the one-to-one property. So the log 4 goes away, the log 4 goes away. We get 3p squared minus 6p equals 6p. Lots of people wanted to add 6p to both sides. That is not helpful because then I'll have p squareds on one side and p's on another. And we need to have all of the p's on one side. So instead, I'm going to subtract 6p to both sides. And we get 3p squared minus 12p equals 0. So let me just show you those notes that we took back in Module 4 to see if it helps jog your memory. So when we're factoring polynomials, we put it in standard form, often equal to 0. We just did that. And then we do the, hey, can I take out a greatest common factor? So we're going to do that next. After that, you do the find ABC, and then we use the X factor and all of those steps, right? So we're going to do the, hey, can we take you out? Take something out, right? First, we look at the numbers. Is there a greatest common factor between 3 and negative 12? There is. We can take out a 3. Then we look at the variables. Can we take something out between p squared and p? We can take out a p. Now we have to see what we're left with. Now I know some of you get confused on how we figure out what's left over, so I want to try to explain it well again. So we are dividing by 3p to both of those terms. 3 divided by 3 is 1. P squared divided by p is p, because that would be like 2 minus 1. P. 12 divided by 3 is 4. P divided by p is 1, so it stays as just p minus 4. That equals 0. From there, we set each of them equal to 0, so we get 3p equals 0. Divide by 3, divide by 3, p equals 0 is one of our answer choices. And then we put p minus 4 equal to 0. Add 4 to both sides. We get p equals a positive 4. That is our other answer choice. But first we need to check. Before we go on to number 10, we need to check and see if any of our logs are going to be 0 when, if any of our logs are going to be negative when we do that. Okay? So let's try it. 0. 0 into 3 times 0 would make it 0. We can have a log of 0. That's fine. Put it into here. 0 minus 2 would give me log base 4 of negative 2. That is not okay. So p cannot equal 0 because we would end up with log base 4 of negative 2. That is not allowed. You can still check the 6 times p, which would be 0. That would be okay. But if it doesn't work in 1, it's not allowed. Then let's try 4. 3 times 4 is 12, so that one's fine. 4 minus 2 would be positive 2, so that one's fine. 6 times 4, I'm not even sure, but I know it'll be positive. So I give it the little check mark to show that I tried, that I checked it, right? So also to be clear, this one is not no solution because this solution does not work, but this solution does work, right? Okay, let's go to number 10. So this one is a log equals a number problem. And we did that on Friday the 13th. So in our notes, it looked like this. We had 5 sections, right? We had our 4 steps here, which are to condense, isolate, put it in exponential form, solve for x, and then check, right? So if you weren't here that day, watch that video, take those notes, right? You might want to write that this is test number 10 in your problem, or in your notebook, so you know where to look. And then the next page of those notes, we did sample problems. You can follow the steps. All right, step 1 is to condense. Well, I only have the word log on one side. And in case you were wondering how I know it's log versus equals number, because I have a log, and on the other side of the equal sign, I have a number. Whereas this one, I have log on one side of the equal sign, and I have log on the other side of the equal sign. I need to isolate. It is already isolated. If it weren't isolated, it would have something weird out here like a -2, and we would have to add 2 to both sides to get rid of it. But we don't have anything else like floating around, hanging around, so we can continue. The next step is to put it into exponential form. Well, that's going to be kind of the same thing that we did for problems 1 and 2, is that we need to know how to go from log B'ni to Ben, right? My best way to help myself is to write it out right there near my problem, because now I can see that the 8 is the B, right? The 8 is the B. So I'm going to write 8 nice and big like this B right here. I can see that the 1/3 is the E. Well, the E goes on top of the B as the exponent. Now all I have left is the N, and it's going to be after the equal sign. The N is this whole part. So 12 minus 3J. And now we have an Algebra 1 problem, right? Not an easy Algebra 1 problem, like he's complicated still, but an Algebra 1 problem. So the 1/3 can be done as a radical sign, so we can do what is the cube root of 8. If you don't know, then you would want to look at the back of your notes, right? Back of my notes has the cube root of 8 equals 2. We also sort of have it in our notes on this page. Thank you for waiting. The page that we wrote practice on whiteboards. Oh, notice I wrote in my notebook that test numbers 1 and 2 are from this section. But at the bottom, we wrote that 2 cubed equals 8. So that should also tell us that the cube root of 8 equals 2. So that means I have 2 equals 12 minus 3J. You could also have written it here. We're solving for J, so I'm going to subtract 12 from both sides. That gives us -10 equals -3J. Divide by -3 to both sides. And I know it's not pretty, but we end up with 10 over 3 equals J. Do not freak out about having to plug in a fraction. You can do this. So we need to check, right? Check our answer. So I'm going to see if 12 minus 3J, I need to see if that's going to be positive or negative. So 12 minus 3, J is 10 over 3. What is 3 times 10 over 3? Well, this is a fraction. We have a 3 on the top, a 3 on the bottom. They cancel. We get 12 minus 10, which is 2, which is positive, so it checks. And that is the entire practice test. Practice it. Try it on your own. Cover up the answers. See if you can do it, without help. That is the goal, being able to do it without help. Good luck.